Hi everyone, I'm Wardah, a STEM Scholar Mentor, and today we'll be starting the third unit of Algebra 1, Expressions and Equations. We'll do the first lesson today, which is dependent and independent variables. So maybe you've heard these terms in your science classes or other classes, but let's go over what these are in math. So the independent variable is also known as the input variable. It can be any value in the domain of the mathematical relation, and it's always plotted on the x-axis. So the independent variable can be any value. It's always on the x-axis. So remember, independent is x. The dependent variable is also known as the output variable. The value depends on what is input. So the dependent always depends on the independent, which is why this is dependent and this is independent, because it can work on its own, it can be any value, and this depends on this. And the dependent variable is always plotted on the y-axis. Independent x and dependent y. So let's go over terms, which is a number, a variable, or the product of numbers and variables. So, terms in an expression are always separated by a plus sign or minus sign. Terms in an expression are always either positive or negative. Numbers and variables connected by the operations of division and multiplication are parts of the same term. Terms together with their signs can be moved around within the same expression without changing the value of the expression. If you move a term from the left expression to the right expression, or from the right expression to the left expression across the equal sign, the plus or minus sign associated with the term must be changed. So basically what this means is that a term is, let's just say, 2x squared. Those are all terms. And when solving an equation or an expression, the terms always have to go to the other side of the equation to keep it equal. So let's just say we have 2x minus 3 equals 0. We'd have to add 3 on both sides, so it would change from minus 3 to plus 3. That's essentially what they're saying. So let's go over some examples together of dependent and independent variables. So here's our mathematical relationship, y equals 2x plus 5. Our independent variable is going to be x because it can be on its own, and our dependent variable is going to be y. Now see, this is asking for independent variable. If they were asking for independent term, we would put 2x plus 5. So another way that you can think of the dependent variable in a mathematical relationship is that it'll always be on the other side of the equation. So we'll see in this next example. So our independent variable is going to be f, because it can go on its own. And then our dependent variable is going to be c, because here we have f basically creates this entire equation. It wouldn't be anything without f. But then c is equal to this entire section. So c is dependent on f. So as you can see, the dependent variable is always on the other side it's on the lighter side of the equation. So these are the heavier sides. Next, we have our independent variable is c, and I'm right. Our independent variable is c, and our dependent variable is f. Yeah. So c is on the heavier side, carries this entire equation, while F's value depends on this whole equation. So just to make it a little bit easier for you guys, let's just say in this equation, we're going to use the easier one, but in this equation, x will substitute for 2. So we know that 2, we wouldn't have any answer for y unless we knew x. Which is why y is the dependent variable and is dependent on x, the independent variable. Okay, so for the next example, our independent variable is r, and our dependent variable is a, for the same reasons. For our last one, our independent variable is t, and our dependent variable is f of t. So this one is a little bit tricky, but as we go on into higher forms of math, we'll learn, or like more units actually, we'll learn that f of t or f of x, anything that you substitute here, it's really just y. So if we were to make this a little bit easier and change the t to x, we just have f of x, and f of x is always y. F of anything you always treat as y. So this would, as we can see in the first one, the first equation, y, dependent variable, x or t, independent variable. So now I want you guys to do a question on your own. Just pause the video for a while and then complete it. Okay, you should have gotten 2 as your answer. So let's go over it. It says the formula for the surface area of a right rectangular prism is A equals 2LW plus 2HW plus 2LH, where L, W, and H represent the length, width, and height, respectively. Which term of this formula is not dependent on the height? So, we're basically looking for, well, okay, let's break this down. So we already know that A is going to be dependent because it's on the lighter side of the equation. This A's value depends on this entire section. So 1 is already out. Next, we see that we have 2LW, 2HW, and 2LH. So they're asking for one that isn't dependent on the height. And 2HW and 2LH have H within their terms. So we know that somewhere we would need the value of H, or the value of the height, in order to find out the rest of this term. So these two are dependent on the height, which leaves us with 2, which doesn't have any H, and it's on the heavier side of the equation. So we know that our answer is 2, which is 2LW. So that's it for today. Thank you for listening, and here's my email if you have any questions, and if you're looking to do any additional practice. JMAP and Khan Academy are some great sources.